Okay, boys and girls, we are going to be starting lesson 2, which what are some types of forces? So we're doing some review, and there's going to be some new information in this part of the chapter. And it says all motion is caused by forces. Changes in motion are caused by forces too. Forces affect everything the skateboarder is doing. And it says, can you explain it? Do you have page 89 in your book? Okay, so we need to be on page 89. And it says, watch the video of indoor skydiving to discover more about how different forces affect an object. So let's watch her.
Get suited up, and then they actually fly. They definitely enjoy the flying the most, but they love the ball demonstration. I think they enjoy learning about the engineering, how the wind tunnels develop through the years. One of the kids' favorite part is watching the teachers, or even better, is watching the principal fly. The kids
Let's redo that. It goes so fast.
get suited up, and then they actually fly. They definitely enjoy the flying the most, but they love the ball demonstration. I think
I don't know why this goes by so fast.
they experience
This video. Okay, video.
the most. STEM is an acronym for science, technology, engineering, and math. It's trying to encourage kids to stay interested in math and science careers. Instead of just approaching them as separate subjects, it's approaching it as a group of information that can be used in the real world. We talk a lot about terminal velocity, the different factors that affect terminal velocity, the things that you can change to change your terminal velocity, the things that are standard for everyone. Then we talk about the different objects that we have, about how they're going to fly in the tunnel. We actually let them throw the balls into the tunnel, and they really love that. Terminal velocity is when the force of gravity is equal to the force of drag, but with the water there's also the force of surface tension. That's the size that has the strongest surface tension, and so the water wants to break up to that size and hold itself together. When we do the parachute activity, I usually make it a bit of a competition and hold 2 at a time and drop parachutes. Once they've done that, they move on to their flight class with the flight instructor, where they watch the safety video, they get suited up, and then they actually fly. They definitely enjoy the flying the most, but they love the ball demonstration. I think they enjoy learning about the engineering, how the wind tunnels develop through the years. One of the kids' favorite part is watching the teachers, or even better, is watching the
principal fly as well. Isn't that cool, boys and girls? Has anybody ever been in one of those wind tunnels?
I really want to go, but
So you've been in one of those?
I got a super high fly when I went all the way up to the fan.
Oh,
I
fun.
was scared that the fan was going to get me into 200 pieces.
Oh yeah, I'd be afraid of that too. So boys and girls. It says, so we watched the video of the indoor skydiving to discover more about how different forces affect an object. So we saw balls in there, we saw water in the tunnel, we saw people in there. So the indoor skydiver flies because a force is acting on her. A cushion of air pushes her up. The instructor applies force to adjust her position because the instructor moves her around. So let me see. Oh, am I going to be able to move this? So can you identify? So I want you to look at the picture. We looked at the video. Can you identify the forces pushing or pulling on the indoor skydiver? Are these forces balanced or unbalanced forces? So what kind of forces do you think they are? How are the forces affecting the motion of this skydiver? What are the forces doing? Yanni, what are the forces doing?
The forces are bringing the people up instead of pushing them this way
So the forces are pushing the skydiver up, okay? You could write that down then. Olive?
Probably unbalanced because they're not touching the ground.
Okay, so you think the forces are unbalanced forces? Okay, write that down. Write down what you think. Write down whatever you think. Because now we're just guessing. So write down your guess. So we're all gonna write down what we think is happening with that skydiver. What are the forces doing? So you're going to write down your guess, what you think the forces are doing. So write down your guess. Write down what you think the forces are doing. Okay? Okay. Did everyone write down what they think the forces are? Or what do you think is happening in there? Logan, did you want to share?
Yeah, when I went there, they didn't have all these crazy, like all the activities. You literally go, you watch the video on directions, you suit up, and they put you out there.
Oh, because this was more like a class, this was more of a field trip, this was more of a learning experience than just going to go in the tunnel. That's why. This was more of a field trip
Yeah, but it's
type of experience where you were learning a lot of different things.
I went there when I turned 7.
Nice. Okay, so now here's what we're going to do. We are going to go to our next page. And we are going to go to our touchy exploration 1. Okay?
We did this one already.
No, we didn't. It has the same people in it, but we haven't done it. So it has some of the same things in it. So it's called pushing back. So boys and girls, this has some new terms in it. So while it looks the same, we're going to be learning more about it. So we're kind of studying the same thing, but we're studying it more in depth. That's what scientists do. They have layers of knowledge. So we're still studying force, but we're adding to our layers of knowledge. So if you push or pull an object by touching it, you apply a contact force to it. Contact, you're making contact with it, right, boys and girls? When you use a contact force to push an object, the object pushes back. If you pull on an object, the object pulls you. Okay? So now that's what happens. So, now can pushes have different strengths and directions? What do you think, Juliana?
Yes.
Yes, for sure they can. Now, can pushes and pulls change the speed or direction of the motion and start and stop it? Ethan?
No. But yeah.
Yeah, they can. They sure can. Now, what happens when objects touch or collide? What happens when objects touch or collide with each other? Think of the game. The hockey, the air hockey game. What happens? Olive?
If it hits the edge, it goes the other direction.
It can go in a different direction. Very good. So, I want us to look at the pictures, okay? I want you to study this playground picture. I want us to look at the places where we see a contact force happening. And I want us to draw pairs of arrows to show the direction of the forces. Now the baseball has already been done for us. So the baseball, boys and girls, is already going. Is this gonna work? There it goes. Okay? So the baseball, you see how the ball is going to hit the bat. The ball is going this way, like that. And the bat is going to hit contact going that way. Do you see how that's working? So do we see another place where we have contact? Where we have contact force. And what is the contact force? What do we think the contact force is? Where's another place where we have contact force? Kelsey?
The swing.
The swing. And so what is the contact force in the swing and what are the directions it's going in?
The dad's pushing it forward and then it's pulling it back
Okay, so which way are my arrows going?
this way.
So is it going, would I go like this, kind of like that one is? Yes. So we're gonna go like this. So draw your arrow so it's like this. Like that, okay? Draw your arrows. Do we see another place where we see contact force? Where's another place where we see contact force? Avery.
The mom pushing the baby shoulder.
Okay, and where are we seeing that, we're seeing that contact force, and how are my arrows going to be?
They're going to come forward. Or they're going to
Like that again? Okay, so the same way, mom's pushing like this. Okay, like that, just like the other one. Do we have more contact force? Juliana,
The kid pulling the turtle.
the kid pulling the turtle, and what does his contact force look like?
Pulling forward.
Is it gonna look like their contact force? Just like all the others? Yes. Okay. Okay, so we have the same contact force. Now it says there's 4 pairs. Do we have 4 pairs? 1, 2, 3, 4. So we have 4 pairs of contact force, so we don't have to draw any more contact force. So that is our contact force. Very good. You were able to find all the contact force. Now, did everybody draw that? Now what we're going to do is we're going to go to the next page, boys and girls, and we're going to complete the following statements. You have them in your book. It says, write the correct answers from the word bank to complete the sentences. And let's look at the words we have in our book, or in the word bank. We have the words push, pull, toward, and away from. And it says, when you blank an object, it moves farther blank from blank you. So what word should we put here? What should be the word? Yes, Ethan?
Push.
When you push an object, so let's see, when you push an object, it moves farther blank you. What word would go there? What word are we gonna put there, Lisa?
Forward.
You think the word toward you? When you push an object, it moves farther toward you. When you push an object, does it move toward you? So if I have this,
Away from.
yeah, because if I have this chair, okay, I have my chair, this is a good example, and I push it, it's moving what? It's moving away. Okay, so away from you. Now our second sentence says, when you blank an object, okay, so what should be next? When I blank an object, Clark, pull an object, it moves closer. Okay, I'm gonna, what would be my answer? Yanni?
Forward.
Toward, okay, toward you. So let's see if that's, let's check it. Well done. So when an object is pushed, it moves farther away, like my rolling chair. And then when it is pulled, it moves closer. I have a sticky wheel though, but it's still moving closer to me. There we go, boys and girls. Good job. Good job. Okay? Now comes the next interesting part. Did everybody mark that? Because I have to erase it, except for the next class. So they don't see all the answers. Oops. Oh no, wrong thing. We're still in this one. We're still in touchy touchy. Now we're on carefully balanced. Oh, this is fun. Now pairs of forces are either balanced or unbalanced. Now you have experienced this in life. Balanced forces are the same size and strength, but act in opposite directions, so there is no motion. And you're thinking, well, what does that mean? We can tell by looking at those dogs. When one force is stronger than the other and the forces act in different directions, they are unbalanced forces. Balanced forces, boys and girls, forces that cancel each other out because they are equal in size and opposite in direction. So if I had somebody right here who is the exact same size as I am,
No.
and they were had the exact same amount of strength, and we both were pulling on a rope, or at least I had somebody who was the exact same strength as I was, and we were each pulling. I'm pulling this way, they're pulling that way, and we had the exact same amount of strength, and we're pulling that rope, and we're not going anywhere because we're pulling the exact same way, okay? Now, if somebody came in the room, or if I had somebody, a kid from preschool come, and they're standing there, and I'm standing here with the rope, and we have, it would be an unbalanced force, because forces that cause a change in an object's motion because they don't cancel each other out. I would be bigger and stronger, right? I would be able to take that preschooler and I would be able to pull them, right? Because it would be an unequal, unbalanced force, because I would be stronger than they are, hopefully. I should be able to pull the preschooler, correct? I mean, I would say one of you, but I don't know if I'd be able to pull everyone in here. I should be able to, I'm going to say might be able to pull Libby. What do you think, Libby? You think I'd be able to pull you? I should be able to pull Libby. I'm not even going to discuss pulling, I don't know. I'm going to say Logan might give me a run for my money though, pulling him. But, so let's look at the pictures here. It says study the pictures and captions to discover more about forces. It says the two dogs are evenly matched. They both pull with a force of 10, so they're pulling with the same amount of force, 10 and 10. Now here, the X marks the center of the rope at the start. The rope hasn't moved even though both dogs are pulling. This is like a tug of war. Now look at this. Now one dog is playing tug of war with a big horse. The horse is stronger and pulls with a force of 40. So is this a balanced force here? What do you think, boys and girls? What do you think, Olive?
Unbalanced.
It's unbalanced. The dog will be pulled over the X in the direction of the horse. Do you see how the dog is moving that way? It started way over here, the dog, but now it's getting pulled because the horse is pulling with a force of 40. But now look what happens. A much stronger elephant takes the place of the dog and pulls against the horse. So now the horse is losing because the elephant has a force of 100 and the horse only has a force of 40. The elephant is much larger and stronger than the horse. You can tell from the arrows that there's more force in the elephant's direction. So now the horse is going to be going that way. So an unbalanced force causes an object's motion to change. What will happen to a moving object that is acted upon by balanced forces? So if it's a balanced force, is its motion going to change? No. If it's two balanced forces, the motion will not change. Okay? So, you can add all the forces that push or pull on an object. This sum is called net force. If the animals pull with equal force, the forces are balanced. This is zero net force. The motion does not change. So if it's the same, it's zero net force and motion will not change. So if force A and force B are both pulling at 40, that's zero net change and zero net force, and motion's not gonna change because nobody's gonna win that. They're pulling at the same amount of force. So let's see if we could predict who is going to win. Are you ready, boys and girls? Who's ready to see who's gonna win here? So big horse A and big horse B. Who do you think is going to win? Is it going to be, who's gonna win? Big horse A, big horse B, or is it going to be a tie? What do you think? Yanni?
Tie.
Tie. Okay, so I'm gonna put that there. Is it balanced or unbalanced? What do you think? Yes?
Balanced.
Balanced, so let's see. Big horse A and adult elephant, who's going to win that? Clark? Big horse A or an adult elephant? Adult elephant. And is it balanced or unbalanced? What do you think? Unbalanced. Balanced. Okay, Johnson. A 10-year-old or an adult, who's gonna be the winner there? An adult. And it's gonna be balanced or unbalanced? Jensen, balanced or unbalanced? Let's see if we're right. Yes, good job. Everybody, you're going to have to put this in your book. Let's write those in your book. Did you write them? Thomas, did you write that in your book? Okay. So an unbalanced force can cause an object's motion to change, which we could see here. No change because it's balanced. Here, unbalanced. There, unbalanced. Very good, boys and girls. Okay. This is all we have time for today, so we're going to stop. Good job.